Hello everybody, this is the time that indefinite integral is started in different schools and coaching center. So everyone, if you see the JEE main paper, and you will hear also that there are very less number of indefinite integrals are coming. But everyone, this is immensely important, because on the basis of indefinite integral, that definite integral, differential equation, area under the curve, even application of derivative, even some chapters of sequence and series and some algebra, just questions are coming. It means, what I want to tell you, that if indefinite integral is not well done, you have to suffer in examination. Even for the board examination also you have to suffer, because its substitution does the matter. So today in this video I will show you some substitution, some standard substitution for JEE Main and JEE Advanced, and next in the next videos I'll solve some standard question, some difficult question on indefinite integral, which are important for the JEE Advanced ISI level sums. Okay, so let us start. So everybody, so let us start some standard level indefinite integral, and whatever I told you, that this substitution is really problem for number of students, and you have to practice number of sums, mainly NCERT. You have to start with the NCERT level question, that so that your substitution becomes habituated. Because in the examination hall, I have seen number of students, those who cannot understand that what exactly you have to substitute, what exactly you have to study. So everyone, I am just doing this class some standard integral. Standard integral means that for very important for the JEE examination, JEE Main and Advanced examination. So let us start with the part 1, indefinite integral. Okay, so what to do for this? In this type of cases, we'll do what we'll do here, everybody. So we'll take x. So we have to take always the main part, target of the indefinite integral is that we have to take something as t whose derivative is present in the sum. So what we'll do? So we'll multiply by x square here, root over of multiply by x in the numerator, denominator x. So x square equal to, if I take as t, so 2x dx equal to dt. So I can write here x dx. Everybody, x dx is removed in terms of half dt by, in this case, what is coming? This is coming to be t into root over of t square minus 1. So this is the direct integral of the sec inverse, but it is, if suppose we forgot that what is the exact integral, what to do? We'll do in this way. Let t equal to sec theta, so dt equal to sec theta tan theta, sec theta tan theta d theta. Therefore we can do this half here sec theta tan theta d theta, and here we can write that is t as sec theta, t square minus 1, that is sec square minus 1 is tan square. So this is tan theta. What I told you, this is the direct integral also possible for this. So I can write here, it's getting cancelled, d theta, that is coming theta plus c. Now we can put the value of the theta, or we can take directly, this is the direct integral, this portion, everybody, it is a direct integral of the sec inverse x. Okay everyone, next I am going to the next sum. So what to do for this? E to the power x into x by 1 plus x whole square. So in this case, what we'll do? So first of all, we have to know one very famous equation. This is extremely important, that e to the power x into fx plus f dash x equal to e to the power x into fx plus c. Therefore, thinking this in mind, we can just, what you have to do in this case, this is extremely important, and this is very, very important for the JEE Main type of examination, because regularly the questions are coming on the basis of this particular type. Okay, so what to do here? We have to present some fx and its derivative. You have to identify that which to take as t and which is its differentiation value. So what we'll do here? So in this case, we'll write e to the power x. So I can write here x plus 1 minus 1 by x plus 1 का whole square dx So I can tell here x plus 1 by x plus 1 whole square, that is 1 by x plus 1 minus 1 by x plus 1 whole square. Remember one thing, integration, indefinite integral is called antiderivative. So you have to practice first on the differentiation, then only you can be able to do the integration well, because in this case if we take this as its derivative, if it is fx, then its derivative is minus 1 by 1 plus x square. So e to the power x into fx plus f dash x is getting satisfied. Therefore, I can write this as e to the power x into fx. It means 1 by 1 plus x plus c, where c is the integration constant. Okay, I am going to the next sum. Suppose this sum, this very good sum. So root x by fourth root of x cube. So everybody remember one thing. Always one thing we have to remember, that we have to take for whenever we'll see any indefinite integral, any substitution. So what to substitute? So what you have to think, that we have to take anything as t whose derivative is present in the sum, whose derivative is present in majority case in the numerator. तो किसको तुमको x लेना, t लेना चाहिए whose derivative is present in the sum, present in the numerator. What will do? In this case, we are seeing that we have to replace root x. So root x is derivative of whom? So let us understand that root x is integration of what? X to the power 3 by 2. So constant is going outside everybody. Therefore, I can write here integration root x dx total divided by 1 plus x to the power 3 by 2 whole to the power half. So I can take x to the power 3 by 2 equal to t. Therefore, 3 by 2 root x dx equal to dt. It is actually not differentiation, it is a differential we'll doing. Differential and differentiation are different. Okay. So I have seen number of persons are telling that this is differentiation. Everybody, it is not differentiation. This is the differential. So what we'll do here, in this case we can write root x dx is 2/3 what is coming here, dt. So it is better if I take it as a t square, it will be better everybody. Then it is coming to be 2t dt. It would be easier for us to calculate because it's a half and t square, root is coming out. We could take t also. So what we'll do here, 2/3, actually it will be 4/3. In this case it is coming to be 4/3. Okay, right, I'm just writing freshly. So this is coming to be 4/3 and t dt by 1 plus what is coming? This is t square whole to the power half. This is coming to be t. So 1 plus t. Now simple substitution cases, everybody, this is very important substitution. Always I am telling about that, not particular this sum. Substitution is very important always. So we can write 4/3. So t plus 1 by t plus 1 dt minus dt by t plus 1. So we can write 4/3. What is coming here? dt ka integration t. So this is coming t minus log of 4/3 is common, log of t plus 1 plus c. Sum is over. Now we can just replace the value of the t. Okay. Next, I am going to the next sum. So in this type of cases, so there are a lot of rules and a lot of rules regulations. So nowadays so much is not needed. So main target is that if there is the much difference of the numerator and denominator with respect to the degree, then better will take the maximum power outside. Or if this works under when there is nothing in the numerator. When there is a numerator and denominator degree difference, I will show you very nice properties, nice sums. Okay. So first of all, what we'll do here? So we can take x to the power 4 outside. So if we take x to the power 4 outside, so it is coming out as x to the power 3 outside x to the power 4. It means we are getting here 1 by x to the power 5 into what is coming, 1 by x to the power 4 plus 3 whole to the power 3 by 4. So we are saying that its derivative is this, dx is it is. its derivative is this. Therefore, I can write here 1 by x to the power 4 plus 1 equal to, what is writing? T. So, minus 4 by x to the power 5 dx equal to dt. Okay. So, dx by x to the power 5 is removed in terms of dt by minus 1/4. Just see one thing and understand that dx by x to the power 5 is removed in terms of dt by 1/4. It means minus 1/4 outside dt by t to the power 3 by 4. So, x to the power n ka derivative, x to the power n plus 1 by n plus 1. So, what we will do now? Just 1/4 t to the power minus 3 by 4 dt. Therefore, 1/4 x to the power n plus 1 by n plus 1 by minus 3 by 4 plus 1 plus c. Now, everybody just put the value of t and replace. That replacement you can do. Okay, everyone? It means always you have to keep in mind two things while doing the integration. One is we have to take something as t whose derivative is present in the sum. Second thing is that if what to take so that we'll get its substitution value, we'll get its reflection value. Next, for example, this sum, actually it was the IIT question. I think it is 2006 IIT or 2008, 2006 or 8 IIT question this is. So what to do here? In this case, what can you do? Let's see. What to do, everybody? In this case also, in the numerator and denominator, degree difference is too much. Numerator is degree is 2, denominator is from here x to the power 4 root means 2. So x to the power 5 is coming in the denominator. So let's try once that we can take the highest power from the root over. Right? So this type of sums, not exactly this sum, is Euler substitution, or somebody is telling Euler substitution. So on the Euler substitution, actually nowadays Euler substitution is not going on, but there are some sums we can solve by Euler substitution which are coming in JEE advanced examination. So I'll just make the videos on this. So everybody, what to do? I am taking x to the power 4 outside. If I take x to the power 4 from the root, so it is coming out as x square, outside x cube. Therefore, I am writing here x to the power 5 in the denominator, and here it is coming to be what? That 2 minus 2 by x square plus 1 by x to the power 4. We got it. Numerator as it is dx. Okay, ready? Now what we'll do? Now what we'll do? First of all, let us divide this x to the power 5 with the numerator. So x square by x to the power 5, 1 by x cube minus 1 by x to the power 5. This was a previous IIT question. I think it is in the time of 2006 or 8 like that. And this is coming root over of 2 minus 2 by x square. You have to understand and know the indefinite integral for the sake of definite integral and differential equation. Don't expect that indefinite integral is coming in the JEE main examination. Remember one thing, if there is an indefinite integral coming in the JEE main examination, it's not so easy. So what we'll do, that 2 minus 2 by x square plus 1 by x to the power 4 as t. So इसका differential क्या होगा? 2 का differential 0, x to the power minus 2. It means minus x to the power, what is the differentiation actually? X to the power minus 2, x to the power minus 2 plus 1 by minus 2 plus 1. So ये होगा plus 2 by x cube. And this is coming what? In this case, what is coming? Minus 2 plus 1. And this is coming what? In this case, x to the power minus 4. So this is coming a x to the power n x to the power n minus 1. So in this case, sorry, this is coming to be what? This is 0. This is minus 2 x to the power minus 2 means what? Minus 2. This is plus 2. by x to the power n minus 1, and this is coming minus 4, and what is coming here, x to the power 5 dx equal to dt. Okay, so let us write in fresh, that is 4 outside, 1 by x cube minus 1 by x to the power 5 dx equal to dt. So everybody, we are getting here we are getting here numerator. So I am writing as numerator is replaced as 1 by 4 dt by t to the power half. Therefore, take it up t to the power minus half dt. So x to the power n ka formula x to the power n plus 1 by n plus 1. So I am writing here, this is coming to be 1/4 t to the power minus half plus 1 by minus half plus 1 plus c. So sum is over. Okay, so I am going to the next sum. This is the root over of 1 plus sec x, what to do? So it is better to convert it sec to cos, cot to tan, like that, cosec to sine. So let's try, then we'll think. So we can write this as root over of 1 plus 1 by cos x. So always you have to keep in mind that whose derivative is present in the sum. So 1 plus cos x by root over of cos x dx. Therefore you can write integration 1 plus cos 2 theta, formula is 2 cos square theta. So in this case root 2, this is coming 2 cos square x by 2. So root 2 is coming out. So root 2 cos x by 2. So whose derivative is cos x by 2, everybody? So in rough cases, so constant is outside. So whose derivative is cos x by 2? Everything like this. So this is coming to be sin x by 2. Therefore I can write here, I have to present 1 minus 2 sin square x by 2. Therefore I can write here root 2 sin x by 2 as t, then directly integration will be solved, because root 2 into half cos x by 2 dx equal to dt. Therefore I can say that is coming to be cos x by 2 dx. Everyone, root 2 cos x by 2 dx is coming to be 2 dt. So 2 dt by root over of 1 minus t square. So this is sin inverse x ka formula, sin inverse t plus n, sum is over. So I will put the value of t. Okay, everybody, I am going to the next. Substitution is extremely important. Everyone, first solve, first try. Those who are doing the substitution from the beginning, just you have started the substitution. So whatever you have to do, everyone, just do the very basic substitution first, because in entrance examination like JEE Main, JEE Advanced examination, substitution exam is not coming easier, and maximum students which I have seen, that number of students are struck in the examination with respect to the integration only in case of definite integral and differential equation and area also. Okay, and these are the very major chapters. So 1 plus 6 dx, one similar type sum. So this is coming to be same thing, 1 plus 1 by cos 3x dx. So I can write here root over of 1 plus cos 3x by cos 3x, right? So same question, same type. So 1 plus cos 2x is 2 cos square x by 2 cos square x. So 1 plus 3x is coming to be root over 2 cos 3x by 2 dx. And in this case, whatever I am writing, whose derivative is same thing, 1 minus 2 sin square 3x by 2. So I have to take same as this before, root 2 sin 3x by 2 equal to t. So directly we are getting, okay, I am solving the sum completely. So its का derivative क्या होगा? Actually differential, that is 3 by 2 cos 3x by 2 dx equal to dt. Therefore, thinking this in mind, I am writing here So root 2 cos 3x by 2 is removed in terms of 2/3 dt by root over of 1 minus t square. Same sum that is coming to be sin inverse x by a. So it is here 2/3 sin inverse t plus c. Okay, everybody. Next, root 10x. So this is very popular integration, and number of time it came in previous entrance examination just with respect to the root 10x, with just calculation with root 10x, method of root 10x also. So with respect to the root 10x, number of question, number of times came in entrance examination, just the method of root 10x. So let's see, I am solving. So everybody, whenever it is the root 10x, what to do? Nothing can be done, just we have to take the sec square x. We have to take tan x as t square, obviously. There is no any another way. There is no any another method, everybody. Okay. So what to do here? Tan x as t square. Tan x equal to t square. So sec square x dx equal to 2t dt. So I can write here that is coming to be sec square x dx is 2t dt, tan x as t square, that is t. In this case, it is coming to be t. Denominator sec square x is 1 plus tan square x. Okay, that is 1 plus tan square x का क्या मतलब 1 plus t to the power 4. So power of tan x is very important. So once in our batch, I had given cube root of tan x, 1 tan to the power 1/5 x का integration. Okay, you can try on this. Integration of tan to the power 1/5 x, integration of tan to the power 1/3 x. Okay, this is a very big number of substitution you have to take here. So you can try. So in this case, what we will do? 2t square. So this type of methods are regularly coming in entrance examination and came also number of times. So what to do here? That is 2t square. So I can write here t square plus 1 plus t square minus 1 divided by 1 plus t to the power 4 dt. I am separating this. Let us do one thing. Let us do some another in the next page. What we'll do now? I am writing the same step. T square plus 1 by t to the power 4 plus 1. Just a minute, everybody. I have to give some space so that I can explain it properly. So, by t to the power 4 plus 1 dt plus t square minus 1 by t to the power 4 plus 1 dt. Now you have to think, everybody. Now this is your knowledge. You have to think that which to take as t, whose derivative is present in the sum. Okay, so কাকে আমরা কি ধরবো যার ডেরিভেটিভ সামের মধ্যে প্রেজেন্ট আছে. So in this case, what we'll do? Let's divide by t square. It is your knowledge on differentiation. Divide by t square, and everyone remember this method is extremely important. This method is extremely important. Number of times in entrance examination this type came. 1 plus 1 by t square dt, that is t square plus 1 by t square plus 1 minus 1 by t square dt by t square plus 1 by t square. Right? Now what we'll do? Whose derivative is numerator? Accordingly, we'll rearrange the denominator. So what we'll do? Whose derivative is the numerator? Let us integrate the numerator. And everyone remember one thing, differentiation knowledge is very important. So t minus 1 by t ka whole square plus 2 plus 1 minus 1 by t square dt, that is a plus b whole square minus 2ab. It depends on your knowledge on differentiation. Before integration, before starting the integration, तुमको differentiation अच्छे से करना चाहिए. So why? Because if I take this as p, its derivative is present here. If we take this as z, suppose its derivative is present here, and sum is solved. What will I do now? What will I do now, everybody? In this case, this as P and this as suppose U. So directly if we just integrate, so T plus I am showing you here. T minus 1 by T equal to P, that is 1 plus 1 by T square dt equal to dP. Similarly here 1 minus 1 by T square dt equal to du. Okay. Now what we'll do? In this case, dP by P square plus 2, that is root 2 square, that 1 by A tan inverse x by a का formula, plus in this case du by u square minus root 2 square, that is 1 by 2a log of x minus a by x plus a formula. You have to keep the formula, everybody. Don't sit with the formula book. You have to keep your formula on your head, now in your head, that you decide. Okay. So 1 by a tan inverse x by a plus 1 by 2a log of x minus a by x plus a plus c. And everybody, this method is extremely important. The sum is extremely important. That is that root tan x ka type integration. Okay. I am going to the next sum. So based on root tan x ka integration, let us solve this sum. What we will do? X square minus 1. So I am just writing here x square, x to the power 4 plus 3x square plus 1. So I have taken extra x balanced by x square. Right, everybody? Right, everybody? Now what we'll do? Divide by x square by root over of x square plus 1 by x square plus 3. So same question, whose derivative is numerator? Okay, you have to practice continuously for this type of sums. These are very frequent. What to do? A plus b whole square minus 2ab plus 1 plus done. X plus 1 by x as t. So 1 minus 1 by x square dx equal to dt. Therefore, I can write here, everybody, it is coming dt by root over t square plus 1. So, and this is the formula, and we can write here log of t plus root over of t square plus 1 plus c. That is the final answer. Let's go to the next sum. So what we'll do? This is the sum where dx by root over of 1 plus root x into root over of x minus x. So actually, whenever this type of sum should be there, our main target will be to take some trigonometric substitution, right? So what to do here? So if we take beta x equal to sine square theta, so dx equal to 2 sine theta cos theta d theta. If we take this, what we will get? In this case, we are getting, this is coming to be dx by 1 plus, not it is dx, this will not be dx, actually it will be 2 sine theta cos theta d theta, and this is coming 1 plus sine x. So 1 plus sine x, we have to make the substitution very easy. So root over of, here it is coming sine square x minus sine to the power 4x. It means from this, if I take the sine square x common, what we are getting, everyone, sine square x cos square x. So it is theta. So once again I am writing this sine square theta minus sine to the power 4 theta. What I want to tell you, that if we take sine square theta common, so 1 minus sine square theta is cos square theta, and from the root over it is coming sine square theta cos square theta coming as sine theta cos theta, right, and it is getting cancelled. So I am writing here 2, so sine theta cos theta. So तुम जितना easy method में sum solve करोगे उतना ही तुम्हारा benefit, because indefinite integral तो generally directly is not coming, but its effect, it means for definite integral, for differential equation, it will be coming as an intermediate. So this is coming sine theta cos theta, right? Therefore I can write here sine theta cos theta cancel. So 1 plus sine theta I can multiply. There are a lot of ways to solve the sum. I can multiply better 1 minus sine theta in the numerator denominator. So we are getting 2. It is coming 1 minus sine theta, denominator 1 minus sine square theta, that is coming to be 1 minus sine square theta is coming, that is coming cos square theta. So 1 by cos square theta, if I separate, 2 is outside, that is sec square theta minus sine theta cos square theta, মানে sine theta by cos theta tan theta, I am just separating, that is coming to be, what is coming, see this sine theta by cos square theta, sine theta by cos theta tan theta into sec theta. So direct integral we are getting everybody. We are getting direct integral. Sec square theta का integration is tan theta আর এটার integration কত 2 tan theta sec theta tan theta মানে হচ্ছে sec theta plus c. So we are getting sec theta plus c. Now we can just simplify and change. So everybody this but everybody you'll put the value in terms of theta, in terms of x, but you have to practice in your home details, because in entrance examination there is a huge problem with the definite integral and differential equation to match with the answer, because whenever sum is very big sum, generally in area actually, since it is a definite integral, so always not problem, but for differential equation is the greatest problem. So to match with the answer you have to complete the sum. You must complete, just change this theta in terms of x, and finally result will be coming, right? I am going to the next sum. What we'll do? Sine 2x by sine to the power 4x plus cos to the power 4x. What I am doing here? In this case, whose derivative, always in your mind this should be playing, that whose derivative is numerator. In maximum cases, in 99% cases, whose derivative is numerator. So whose derivative numerator? Sine 2x का derivative क्या है? Cos 2x. I am not taking constant and any other. Just simple cos 2x you have to present in the denominator, right? That should be our target. Once your mindset will be like this, your sum will be easier and you can solve the sum easily, right? Because for any entrance examination, remember that calculus does the matter. Calculus is everything almost. So sine to the power 4x plus cos to the power 4x, that is coming to be sine square x plus cos square x whole square. It means 1 minus 2 sine square x cos square x, that is I am writing to be half sine square 2x, right? So our target is cos 2x. So I am writing here sine 2x dx by 1 minus half 1 minus cos square 2x. Our work is done. Now let us simplify and we'll take cos 2x equal to t. We are getting the direct integral. Okay, let us do this. So I am just simplifying the denominator. We are getting sine 2x dx, and denominator you see one thing, so that is 2 minus 1, that is coming to be 1, and that is what? Minus plus cos square 2x. If I take cos 2x equal to t, that is sine 2x dx equal to minus dt by 2, because cos 2x का differential क्या होता है? That is minus 2 sine 2x. So I am taking minus 2 in the right hand side. Therefore sine 2x dx is removed in terms of minus half dt by 1 plus t square. It is the direct formula dx by x square plus a square, that is 1 by a tan inverse x by a. Therefore, I can write here minus half tan inverse t plus c, and now we can change it t to the cos 2x and that original x part. Okay, right? So I am going to the next problem. What is this? Dx by 3 minus cos x. What we'll do here? So, right, there are a lot of ways to solve. So whenever we'll see this type of sums, so in our mind, one thing will be coming that just express cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2. Everybody, one more thing, for integration to do, you have to do the multiple submultiple angle very nicely. So I can write here dx by 3 minus 1 minus tan square x by 2 by 1 plus tan square x by 2. Okay, just calculate LCM. 1 plus tan square x by 2 coming out up as 6 square x by 2, denominator 3 minus 1 2 minus, that is 3 tan square plus tan square, that is 4 tan square x by 2. Right, I am taking 2 outside, and if I take tan x by 2 as t, because its derivative is directly present in the sum, right? Therefore, I can write here that is tan x by 2, or better, I can write root 2 tan x by 2, tan x by 2 equal to t, that is root 2 sec square x by 2 dx equal to 2 dt, that is denominator 2 is coming in the right hand side. So I can write here, I am taking 2 out, and sec square x dx is 2 by 2 out. So sec square x dx is coming to be what? 1 by 2 root 2 once again. Now 2 by root 2. So what is here? Sec square x dx is coming here. 2 by root 2 means root 2. Root 2 dt, that is root 2 dt by, in this case, what is coming? 1 plus directly t square, because if we have taken 2 common, that is root 2 tan x by 2 whole square, right? So directly this is the calculation. So let us check once. 3 minus 1 2 and 3 tan square plus tan square, absolutely right, absolutely right. Therefore, we are writing here 1 by root 2, that is tan inverse t plus c. Sum is over. Okay, everyone, let us go to the next sum. What I want to tell you, that this is one very special sum. This sum maximum students are solving, in maximum books also, maximum teachers are solving by partial fraction. So everybody will not go to the partial fraction, because a by b by c by d by is too much time taking. So let us calculate. I am showing you one method, and you must practice this method, because in entrance examination this type of sums are frequently coming, generally in differential equation type of sums, right? So I am solving the sum without a by b by c by. So let's see. First of all, in every stage our target is to go to the cancellation. So x square into 1 by x into 1 plus x dx. Right? Now I am just separating this portion. I'll partially separate, but without using a by b by c by, right? So that our time will be something safe. So 1 by x square. So I can write here 1 by x minus 1 by 1 plus x. You check once, if we do the calculate, that 1 plus x minus x, numerator is coming 1. Here numerator is coming 1. Now we can separate continuously like this. So 1 by x cube dx minus, once again, 1 by x square into 1 plus x. Right, everybody? So once again same method. That is x to the power minus 3 dx, and we are writing like this 1 by x into 1 by x into 1 plus x. 1 second separation method. 1 second will separate. So what we'll do? That is x to the power, just let us finish this. Minus 3 plus 1 minus 1 second 1 by x. So we'll separate like this. That is 1 by x minus 1 by 1 plus x. Okay, everybody? Tale, this is minus 2 in the denominator, minus 2x square minus x to the power minus 2 dx, x into x, x to the power minus 2. Once again, same thing. Once again, minus minus plus. So 1 by x into x plus 1. Like this will separate. So I am just what to do? In the same sheet I am solving the sum. It will be easier for us to calculate. I am writing here. So minus 1 by 2x, and this is x to the power minus 2 plus 1 by minus 2 plus 1 minus 1 by x. Minus minus plus. That is minus, what is coming? 2x square plus 1 by x. And once again we can write this 1 by x minus 1 by x plus 1. This is coming to be dx. So minus 2 by x square plus 1 by x plus dx by x, we know that log x, and dx by x plus 1 is log of x plus 1. So log actually ln. So in mathematics में log ln, in mathematics में log, calculus का मतलब log is ln actually, plus c is the final answer. So everybody, this type of sums in every places I have seen they are solving by a by b by c by d by, but no, not in this way. It is a time taking. Better we have to solve like this. It will be easier for us, and regularly this type of sums are coming in entrance examination. Okay, one more question. Cos x plus x sin x by x into x plus cos x. So what to do? Always there will be playing in our mind that we have to take something as t whose derivative is present in the sum. Always remember this. So what we'll do? In this case, whatever we are doing, that cos x plus x, I am adding minus x plus x sin x by x into x plus cos x dx. So we can say here x plus cos x by x into x plus cos x, right? Dx minus, if I take from this side, from this I am separating, because there are two ways. Either we have to cancel, otherwise you have to take anything as t whose derivative is present in the sum. So I can write here minus x 1 minus sin x dx divided by x into x plus cos x, right? So this is getting cancelled, everybody. This is getting cancelled, and so this is dx by x is log x is coming, minus this x is getting cancelled, and we are getting here, if we take denominator as t whose derivative is present in the sum, so I can write directly here, that is x plus cos x equal to t. So 1 minus sin x dx equal to dt. Therefore this is coming dt by t. Therefore dx by x is log x minus dt by t is log t plus c. Okay, so always whenever you solve the JEE examination or for board exam, school exam, whatever you sum in indefinite integral, this is the substitution does the matter. Substitution is everything. So you have to practice continuously on the basis of substitution. Okay, I am going to the next sum. What to do for this? Dx by sin qx, and these are very popular sum, and you have to practice continuously, because regularly in entrance examination, in the middle step, in the main step, questions are coming on the basis of all these sums. Okay, must practice all the sums. So what we'll do here? So sine cube x, sine of x plus alpha. So let us open the sine of x plus alpha. Let's see what can be done. So I can I can open the sine of x plus alpha. So I am writing here dx by, I am not writing sine to the power 3. So sine x cos alpha plus cos x sine alpha, right? Sine cube is there. Dekho, we have to take something out of the root over, because within root over nothing can be done, and we have to take anything as t. We have to think anything as t whose derivative is present in the sum. So what we'll do here, I am multiplying sine to the power sine x in the root over, so it is coming sine to the power x balanced by sine x. So sine to the power x outside the root over is coming as sine square x, and up is cosec square x. So this is coming to be cosec square x dx total divided by root over, what is that? Sin x and sin x cancel, that is cos alpha plus cos x by sin x, that is cot x into sin alpha. Cot x into sin alpha. In this way you have to prepare, because all alpha to obviously constant, but cot x ka derivative is cosec square x. So its derivative is present. Actually differential is present in the sum. So what we'll do here, everybody? In this case, we'll write let cot x sin alpha plus cos alpha equal to t square. So done. Cot x is minus cosec square x, so minus sin alpha cosec square x dx equal to 2t dt, because cos alpha is a constant number, its differential is 0. Therefore I can write here minus cosec square x dx is minus 2 by sin alpha cosec square x dx is, that is t, and denominator is root over t square, and it is getting cancelled, everybody. So dt ka integration minus 2 cosec alpha dt ka integration t plus c. So sum is over. Right? Now you can just replace the t in terms of the original value. So everyone, this is the sum. So this type of sums means we have to calculate in such a way so that the terms are getting cancelled. You have to identify the sums. By seeing the sum, you have to identify. To go indefinite integral, you have to practice in such a way that it will be totally comfortable for you for the examination, because maximum student ka mind mein it is there that what to substitute, what to take. Okay, so I am solving some this type of sums next in some another videos, in the series of other videos. I'll show you step by step sums. So actually I'll make one video for the JEE Advanced and ISI also. Okay, so let us do one thing. What to do in this case? What to do? Let us separate first. So e to the power sin x into cos x into x dx. Obviously by parts is needed. Minus e to the power sin x into sec x tan x dx. So everybody, what we'll do? First of all, what can be done, everyone? This as the first function and this as the second function. Because if we take sin x as t, its derivative is cos x. So e to the power sin x into cos x, हम लोग को ऐसे करके preparation करना पड़ेगा, so that for entrance examination nowadays not easy questions are coming, everybody. Too much practice is needed and relevant practice material is very much needed, and you have to practice. Acha, this is once, and then what we'll do? This is u on a first function, and this is the sec x tan x. Which is the better integrable function, we'll think as the second function, right? So what we'll do? Constant, first function constant x integration of e to the power sin x cos x. What will do? Sin x as t, cos x dx dt. So e to the power t is मतलब e to the power sin x. The integration of e to the power sin x into cos x is e to the power sin x minus derivative of first function x का derivative 1. Integration of the second function तो obviously e to the power sin x on total dx minus, let's see what is coming here, u my first function outside, so e to the power sin x, integration of the second function sec x sin x integration is sec x, so integration of second function is sec x, right, minus derivative of first function e to the power sin x का derivative क्या होगा, e to the power sin x into cos x. So I am writing here e to the power sin x into cos x. Integration of the second function, that is coming to be sec x on total dx. So everybody, let us go to the cancellation. So cos x and sec x, and this is minus minus plus, minus minus plus. Okay, I am writing one more step. X e to the power sin x minus e to the power sin x dx minus e to the power sin x into sec x minus minus plus e to the power sin x dx. So this will go to the cancellation, this integration will go to the cancellation. So everybody, you have to practice in such a way that by seeing the sum you can identify that what is going on. I'll just give more and more such sums. So we are getting the final answer, x e to the power sin x, x minus sec x into e to the power sin x plus c. Okay everybody, let's go to the next sum. Dx by sin x plus sec x. What to do for this dx by sin x plus sec x? In this case, first of all, so we have to do in this way. We have to take, I am changing the color of the pen, it will be easier for you to understand. So dx by sin x sec x is 1 by cos x. So I can write here cos x dx by sin x cos x plus 1. So sin x cos x means sin to x you have to get. So I am multiplying 2 in the numerator denominator. So if I multiply 2 in the numerator denominator, 2, this is denominator also 2. So what we are getting here? We are getting everybody, that is 2 cos x, and denominator I am writing sin 2x plus 2 and numerator 2 cos x. 2 cos x is there. What will do? What to do here? 2 cos x can be written as sin x plus cos x plus cos sin x minus cos x. It's cos x minus sin x. So we can write cos x plus sin x plus cos x minus sin x, right, dx. Therefore I can separate from the middle. यहाँ से separate करो, एखान থেকে আমরা separate করবো, তাহলে আমরা কি পাচ্ছি, that is cos x, and we have to remember, always you have to think that we have to take as t whose derivative is present in the sum, right? Cos x plus sin x dx by 2 plus sin 2x minus, not minus, I am writing plus, this is cos x minus sin x by 2 plus sin 2x dx. So first of all, whose derivative is numerator? Cos x plus sin x, किसका derivative? Cos x minus sin x. अरे minus plus constant number तो will go outside, right? So what we'll do? We have to present here cos x minus sin x. So cos x plus sin x dx, I am writing here, that is 2 plus 1 plus sin 2x minus 1 dx. So I am writing here so that we can understand this thing well. Plus, this is whose derivative is cos x minus sin x. I can write cos x plus sin x. I can get cos x plus sin x in the denominator. So what we'll do? 1 plus sin 2x. Right? I am just writing this all part in the once again in the next page. So it will be easier for us. Cos x plus sin x dx. Integration cos x plus sin x dx divided by 2 plus 1. If I take minus common, so 1 minus sin 2x, that is sin x minus cos x whole square, right? So I can write here 3 minus sin x minus cos x whole square, right everybody? And let comes to this. Once again I am telling you, if I take the minus common, 1 minus sin 2x, 1 means sin square x plus cos square x, sin 2x is 2 sin x cos x, that is sin x minus cos x whole square. Similarly, if I take 1 here, 1 plus sin 2x, that is sin x plus cos x whole square, because 1 का मतलब sin square x plus cos square x, sin 2x is 2 sin x cos x, that is sin x plus cos x whole square. So I can write here that is cos x minus sin x plus cos x minus sin x by 1 plus sin x plus cos x whole square, right? What we'll do now? In this case, sin x minus cos x has t. So sin x का डेरिवेटिव क्या होगा? cos x का डेरिवेटिव क्या होगा? minus sin x. So directly we are getting dt by 3 का मतलब root 3 square minus t square. Direct formula of that 6 formulas, 6 essential formulas. Okay, and in this case plus, so cos x minus sin x. So sin x plus cos x, if we take as t directly, if we take this as p, so what we are getting? Cos x minus sin x directly, that is dp by 1 plus p square, directly formula 1 by a tan inverse x by a का formula. So we are getting here, that is 1 by 2a log of a plus x by a minus x, and plus, that is tan inverse p plus c, and finally you have to take the values and check the values. Okay everyone, let's go to the next sum. Let's solve next sum. So in this case, what we'll do? First of all, tan a minus b formula, let us apply. And by seeing the sum, you have to identify that the sum is totally based on that root tan x integral. So what I'll do this here, in this case, I am doing tan x minus 1 by tan x plus 1. Okay, and that numerator cos square x is there. I am taking up, this is coming to be sec square x. So it is coming to be sec square x dx, and denominator, this is as it is. So tan cube x. So this sum can be solved in very short step. Just I am showing you. So I am dividing by tan x minus 1 in the numerator denominator. So this is coming in the numerator denominator tan x plus 1. So tan x plus 1 ka whole square, tan square x minus 1. Now I am dividing by tan square x. If I divide numerator denominator by tan square x, what we are getting? We are getting here 1 minus 1 by tan square x into sec square x, because tan the derivative is present, so we have no tension. And I have divided by tan square x, so we have to divide denominator also by tan square x, and we have to distribute the tan x, like if we divide this by tan x, this by tan x, right? So what we'll do? That is, if we divide, open the whole square and this divide by tan x, so we are getting tan x plus 1 by tan x plus plus 2 plus 2, and in the root of r, if we divide by tan x, it will enter in the root of r as tan square x. So tan cube x by tan square x, that is tan x plus 1 by tan x plus 1. Now our work is over. So it is easier for us to understand the thing. What we'll do now, I am just taking that tan x plus 1 by tan x plus 1 equal to t square, because its derivative is present. So always we have to think that whose derivative is present in the sum actually. So what we'll do, tan the derivative sec square x. So this is coming sec square x plus 1 by tan x, 1 tan to the power minus 1 minus 1 by tan square x minus 1 by tan square x into sec square x dx equal to 2t dt. Therefore 1 minus 1 by tan square x into sec square x dx equal to 2t dt. So numerator is removed as 2t dt. Denominator is coming what? This is t square and this is t square plus 1, because this is coming t. So t square, 2 is 1 plus 1. So t square plus 1. So what is coming here? Numerator is coming, I am writing here. Numerator is coming what everybody? That is 2t dt. Denominator is coming t square plus 1 into root of r of t square. So directly you have to do, actually I thought that we have to go to the next page, but not needed. T square plus 1, so 1 x square plus a square, denominator is 1 by 8 and inverse x by a formula. So directly you are getting here, that is 2 tan inverse t plus c. Now put the value of t. Okay, ready? I am going to the next sum. This type of sums also very frequent for entrance examination. What to do for this type of sums? In this case, we have to take maximum power outside. So what I will do here, in this case, we have to do dx. I have to take x to the power 41 outside, so it is coming out as x to the power 42. So this is coming x to the power 42 into 1 plus 1 by x to the power 41, right? I am writing 1 plus 1 by x to the power 41 as t. इसका डेरिवेटिव क्या होगा? Minus 41 into 1 by x to the power 42 dx equal to dt. Therefore, dx by x to the power 42, everybody see and understand that dx by x to the power 42 is removed in terms of minus 1 by 41 dt. So dt by t, we are getting log t plus c. So this type of videos for the JEE and advanced continuously I am getting this. So stay connected. Bye everybody.